All right, so on this problem, we're going to be approximating the value of natural log of 1.5 using a third order Taylor polynomial centered at x equals 1, and then figure out what the error in our approximation is. All right, so the first thing we're going to need to do is figure out some derivatives here. So let's go ahead and start doing those. First thing we've got is the function f of x is equal to ln of x. The first derivative is equal to 1 over x, which is x to the negative 1. And we'll use that form because it's easier for taking derivative. And that will give us negative x to the negative 2 for the second derivative. The third derivative at x will be 2x to the negative 3. And that is what we will need for the third order Taylor polynomial. But since we are doing the error, we are also going to need the next derivative, which is negative 6x to the negative 4. All right, so let me just convert these real quick. 2 over x cubed here, and negative 6 over x to the 4th here. Now we are also evaluating these at x equals 1 because that is the center of our Taylor polynomial. So f of 1 is 0, f prime of 1 is 1, f double prime is negative 1, the third derivative is 2, and the fourth derivative at 1 is 6. Now we're using 6 because on the error we are using an absolute value on this. All right, so the Taylor polynomial, that's going to be P3 of x is equal to x minus 1 because our first term would have been a 0, and so that goes away. So the next term is going to be 1 times x minus 1. This is your center. All right, so continuing on with our polynomial here, it's going to be 1 over, or actually 1 minus 1 over 2 factorial times x minus 1 squared plus 2 over 3 factorial x minus 1 cubed. All right, so we could simplify this a little bit here. Let me just go ahead and do so. This will be x minus 1 minus 1/2 plus 1/3 x minus 1 cubed. Now we are going to be evaluating this Taylor polynomial at x equals 1/2. At x equals 1.5, I'm sorry. So we have P3 of 1.5. And then when you substitute 1.5 in, you have this minus 1/2 plus 1/3 cubed. So then we have 1/2 minus 1/2 squared, or 1/2 times 1/2 squared rather, plus 1/3 times 1/2 cubed, and if you work all this out, you end up with 5 over 12, which is 0.5 4, 1, 6, 6, and repeating. All right, so what about our error then? All right, well, the error is absolute value r sub 3 of x, and it's going to be the fourth factorial in the denominator. Our x value is 1.5 minus the 1 to the fourth power, and then the numerator here comes from our fourth derivative evaluated at 1, and so that's going to end up being 6 here, and this comes out to 1/4 when you reduce it, multiplied by a half raised to the fourth power, which is 1/64, and that's about 0.015625. And so that is going to be the error involved in this approximation. So we're about 15 thousandths within the actual value of natural log of 1.5. All right, so on this one, we're going to use a fourth order Maclaurin polynomial. So we are centered at x equals 0 for f of x equals e to the x to approximate e, which means e raised to the first power. Estimate the error in approximation using Lagrange Error Bound. All right, so we already know the Taylor polynomial for e to the x. We've taken care of that before. And so fourth degree would be 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the fourth over 4 factorial. Now what we're trying to do is approximate e to the first, and so we're just going to substitute 1 in. And if you work all this out as a decimal, it comes out to 2.70833. And now we're going to take a look at our error. And so the error involved here is going to be at 1. It's got to be less than, and this is going to be 5 factorial times 1 minus 0 to the 5th power. All right, so what do we put up here then? Well, we know that the fourth derivative of e to the x is e to the x. And we are doing this at x equals 1. Well, we know that e is less than 3. And 3 to the first power means that this we're going to use as 3. All right. Now, could we technically have used 2.73 or 2.72 and said it's less than this? Well, yes, but that kind of defeats the purpose, because what we're trying to do is approximate the value of e. And if we use the value of e in our approximation or the error, then there really was no purpose in doing getting an approximation with an error involved here. All right. And this comes out to be less than or equal to 1 over 40. And so we're going to estimate the error in approximating sine of negative 0.3 with a third degree Taylor polynomial. All right, so with this, we know that the sine of x for a third degree Taylor polynomial is x minus x cubed over 3 factorial. And we know that if we do our third derivative, the third derivative would end up being negative cosine of x. All right, so what we're trying to do, and it doesn't ask us really to approximate the value of sine of negative 0.3. All it's asking us to do is find the error on a third degree Maclaurin polynomial. So the error involved here is going to be absolute value of r sub 3 of negative 0.3. That has to be less than, and since this is a third degree Maclaurin polynomial, you're going to have 4 factorial and then 0.3 minus 0, negative 0.3 minus 0 to the 4th power here. And from previous problems, we know that the maximum value of this would have to be 1. So we're going to end up with a 1 here. And if we simplify this out and make it into a decimal, and since we have a 0.3 on here, this comes out to 0.000338. And that is the error that is involved in our approximation on this. And that is a pretty good approximation for just a third degree Maclaurin polynomial. All right, so the next one says let f of x equal cosine of 2x plus pi over 3. Estimate the error in approximating, and we're going to approximate at 2 points. The first one is 0.1, and then the second one is going to be negative 0.2. All right, so let's start out with part A. We need to build our derivatives. So f of x is cosine 2x plus pi over 3. The first derivative is going to be negative 2 sine 2x plus pi over 3. Second derivative, negative 4 cosine. And the third derivative, and once again we are using a third derivative because it is asking us to find a second degree Maclaurin polynomial. We're using that for the approximation. So we have to do n plus 1 derivatives. All right, so the error of our second degree polynomial at 0.1 has to be less than or equal to, and you're going to have 3 factorial in your denominator, and 0.1 minus 0 to the third power right here. And we know that the maximum value of sine of something is going to be 1. But this now makes it 8 times 1. And so the maximum value of our derivative then is going to be 8 on this. All right, so that's going to give us less than or equal to 1 over 750, which is 0.00133. All right, so part B, we're going to be finding the error on the same polynomial, but evaluated at negative 0.2. So it's got to be less than or equal to, once again, we're going to have 3 factorial. And this time it's going to be negative 0.2 minus 0 to the third power, and still 8 up here for the same reason as before. And so that means this comes out to be less than or equal to 0.01066. All right, so if you compare these two things, 0.1 is closer to the center than negative 0.2, the center being 0 in this problem. Since 0.1 is closer to the center, that means we're going to have less error involved in the approximation, because the further you get away from the center, the more error you are going to have.